Today we're going to look at plotting angles in standard position. Okay, so I don't think you've had, unless you were in Math 2 Honors. If you're in Math 2 Honors last year, then you had some experience doing this. But if you were not in Math 2 Honors, if you're in Basic Math 2, you haven't had this background. So I'm going to go over a couple definitions here. Standard position of an angle. An angle in standard position is if its vertex is located at the origin and one ray is on the positive x-axis. The ray on the x-axis is called the initial side, and the ray on the other ray is called the terminal side. So an angle has two rays and a vertex. And so we have this little picture here. You see its vertex is at 0, 0. Initial, meaning starting side, is always pointing the positive x-axis, so that would be pointed at 0 degrees. And then we move in the positive direction counterclockwise. And so wherever we stop, that's our terminal or ending side. Okay. And then there's a couple of side notes here. Positive angles generated counterclockwise rotation from the initial ray to the terminal ray, and negative angles go the clockwise rotation. And so let's look at a couple examples here. Well, actually, before we do, let's just review quadrants. Okay, your x and y axis split things into four corners or quadrants. And so quadrant 1 is the top right-hand side, and sometimes I'll be using Roman numerals. Quadrant 2 is the top left. Quadrant 3, bottom left, and quadrant 4, bottom right. So here we're asked to do a few things. A, to sketch each of the following angles in standard position. And then B, identify the quadrant in which the terminating ray resides. And that's what we're going to do, just A and B right now, and then we'll talk about C, finding the reference angle. Okay. So if I want to sketch 170 degrees, this is always the starting spot right here. Positive x-axis, that's my 0 degrees. 170 is positive, so I'm going to move in the counterclockwise direction. Here's 90 degrees. Half circle would be 180 degrees. And I've already gone a little too far, right? 170 is somewhere between 90 and 180. Don't have to be exact, but it's closer to 180. And so this right here would represent our 170 degree angle, and that's in which quadrant? 2. Okay. You can use either. Okay. 210 degrees. Same way, you start same spot, start 0 degrees. That's your initial ray or starting point, and you're moving. 210 is positive, so we're moving the counterclockwise direction, counting by 90s until we get a little past 210. So what's the next one? 270 degrees. Okay, and so 210 is somewhere between 180 and 270, closer to what? Closer to 180. So 210, somewhere right here. Which quadrant? 3. Okay. We're going to come back to the reference angles. Okay. Just want you to get this part down right now. All right, so go ahead and do the next two. Find 320 degrees and 70 degrees and state what quadrants they're in. Okay, so 320 degrees, here's the starting point. Moving the positive direction, counting by 90s. And the thing with this is you can keep going around that circle. So if I go back another 90s, at the same spot we had 0, that's also 360. And I could keep going. same spot, I have 90, I can add another 90 to the 360 and get what? 450. Okay, so you can go around the circle as many times as you want. Okay, so there you have more than one representation at that location. So, anyways, 320 is between 270 and 360. Closer to which one? Little bit closer to 360, right? So 320 right here, and so that's in quadrant 3. And 70 degrees, you guys should have. Yeah, I was just checking to make sure you guys are paying attention. It's quadrant 4. 70 is between 0 and 90, closer to 90, in quadrant 1. Okay. The next row of angles here, we have negative angles. And how would we find negative 70? Go clockwise. Still start at the positive x-axis, that's 0 degrees, but now we're going the negative direction. This would be negative 90, and negative 70 would be between 0 and negative 90. So that would be in quadrant 4. Okay. So finish the next 3. So 100, negative 100 degrees. Here's 0, going negative direction, negative 90. Here's negative 180. And so negative 100 is going to be close to the negative 90, but in quadrant what? Quadrant 3. Okay. How about 620? What quadrant are you finding that in? Okay. So which way do I go? Clockwise or counterclockwise? It's positive. So I'm counting by 90. Counting by 90. And when you count by 90, just think multiples of 9 with the 0 at the end, right? So 27, 36, 45, 54, 63, right? Okay. Okay. So 620 is between 540 and 630, close to the 630. So it's going to be in quadrant 3. And then the last one, negative 300, where do you guys find that one? Where's it going to be? 1. Okay. All right. So you have to, this is putting an angle in standard position. We put an angle in standard position really to help us find the next thing, which is the reference angle. And so let's go back up here. We have a definition to work with. Okay. Associated with every angle drawn in standard position, there's another angle called the reference angle. Okay. The reference angle is, and let's add this word in, is the positive acute angle. Acute means what? Less than 90. Okay, so it's got to be a positive angle. It's got to be less than 90. Okay, and then the other thing, it's formed by the terminal side. Okay, the terminal side and the x-axis, not the y-axis. Always to the x-axis. Very important there. Reference angles may appear in all 4 quadrants, and there's 4 examples here. Okay, so in quadrant 1, this is our, I'll put T here for terminal side, and then here's our x-axis, I'll highlight, right? And so you're looking at the angle between that terminal side and the x-axis. In the second one right next to it, 120 degrees goes all the way to quadrant 2. But 120 is not our reference angle. That's bigger than 90 degrees. And so here's our terminal side. Do I go to the y-axis? No, we go to the x-axis always. So I go here, and you see that angle between is 60 degrees. 60 would be our reference angle. Okay. If we're in quadrant 240 degrees, that's a lot. That's not an acute angle. Here's our terminal side. Don't go to the y-axis. Go to the x-axis from there, and so this right here, our 60-degree angle, is our reference angle. And then last, if it's in quadrant 4, here's an example, 315 degrees. That's our angle, not acute. And so you go from this terminal side to the x-axis, and you get 45 degrees. Okay. And so we're going to practice finding these reference angles. Very important that you can do this the correct way. Okay. Ooh. Question. Back here? Okay. Terminal just means the ending side. So if we have an angle, right, we start at 0 degrees. Okay, and so an angle is created by two sides. So this right here is what we call the starting or the initial side. And then we build our angle, say it's 30 degrees. So I go this direction 30 degrees, and I draw my other side of the angle, and this other side is the terminal side. Terminal just means where you stop. Yeah. Okay. So let's practice this with the first example here. So we've already plotted 170 degrees. So the reference angle is between that 170, that's our terminal, and the x-axis, which is that 180. So what's the difference? And it's always positive. What's the positive difference between 180 and 170? We get 10. And so that angle right in there, 10 degrees, is our reference angle. Okay. Let's look at the one below it, negative 70. So a negative 70, that's the terminal side. And we want to always don't go to the negative 90 because that's on the y-axis. Go to the x-axis, which would be 0. And so we're looking at the difference between them. And it's got to be a positive difference because the reference angle is always positive. So you could just say, well, what's 70 minus 0? 70. So 70 is our reference angle. So right in here, 70 degrees. Okay. How about this one right here, 620? The reference angle has to be acute, so it has to be smaller than 90. What would the reference angle be here? So you got your 620 is the terminal side, and what number would I pick on the x-axis? The 540. So we're looking at the difference between those. 620 minus 540, which is 80 degrees. And so 80 would be our reference angle. Okay. So find the reference angles of the other ones that we haven't done yet. Just work through those, see if you can pick out what the reference angles are. Okay. For 210, I'm going to call on a few of you, just ask what you came up with, okay? Isaiah, what did you get for the reference angle for 210? 30. Because we're subtracting 180 from 210, finding that angle in there. When we go 210 minus 180, you get 30. So our reference angle should be 30 degrees. Good. 320 degrees. Cassie, what did you get for the reference angle for 320? And how'd you get that? Guys, what'd you say? Okay, 320 is good. That's your terminal site. But notice where 270 is. That's on the y-axis. And you always have to go to the x-axis. So instead of going to 270, you want to go to 360. And so that will change your number a little bit. So if I go 360 minus 320, that's going to give us what, Cassie? 40. Good. All right. And it's very tempting sometimes to go to the y-axis. So we want to clear that up now so we don't do that in the future. Okay. 70 degrees, we want the reference angle of this one. Jaron, what'd you get? 70. Right, because you're looking at the difference between 70 and 0, which is just 70. So in quadrant 1, that often happens, unless you're going around the circle more than once. Next one that we haven't done is negative 100 degrees. Maddie, did you get that one? 80, perfect. Positive or negative 80? Which one? The reference angle is always positive. Just check and make sure you got that. So we're looking at the difference between 100 and 180, which is 80. Okay. Next one, we did 620. So the last one that we haven't done is negative 300. Jasmine, did you get that one? Perfect. We're looking at the difference between negative 360 and negative 300, which is 60 degrees. Keep it positive, okay? Okay, so we are now going to take a look at the next page of notes. And our instructions are to find the missing coordinate for the point on the unit circle. Hold on a second. Connection issues. Yeah, there we go. Okay. Okay, so part A, want to find the missing coordinate of the point on the unit circle. So as we said before, when you have a triangle drawn in the xy coordinate axes, you always have this idea. So the x and y coordinate, the x value is your base length. The only thing that's different though is typically length is positive, right? But because we're working within coordinates and we're in quadrant 2, we're going to say the x value is negative because all x values are negative in quadrant 2. And then the y value is the height of this triangle, which we don't know and we want to find. And so to find this, if you know two side lengths, so we know the x side length, we'll say negative 4/5 or just 4/5. And you have your hypotenuse at 1. We're looking for y. We can use the Pythagorean theorem. We can say that y squared plus negative 4/5 squared is equal to 1 squared. And yes, it does have a fraction, but it will work out. Okay. So when we square that fraction, you square the numerator and the denominator, and you end up with y squared is 16, or plus, not equals, plus 16 over 25 is equal to 1. And if you're comfortable with fractions, you could leave it as a fraction and solve it. If you're not, you can multiply all three terms by the denominator, so I'll do that. And so if I multiply y squared by 25, I get 25y squared. If I multiply my fraction by 25, the 25's cancel out and I get 16. And if I multiply 1 by 25, I get 25. So I got rid of the fraction. Still solving for y squared. So subtract 16. And then divide by 25. And you end up with y squared is 9 over 25. Then you take the square root. Both 9 and 25 are perfect squares, so we're going to get y is 3 over 5. And when you take the square root, it could be positive or negative, and you have to decide based on what quadrant you're in. So we're in quadrant 2, so should it be positive or negative? Positive. And so now we found that y value 3/5, and we found our missing coordinate. Okay? So then that's part A. Part B says to find the simplified sine, cosine, and tangent ratios of our angle. Again, when we're working within the unit circle or within the x and y coordinate axes, your reference angle is always going to come from the point or the vertex at 0, 0. Never get your reference angle will never be the other angle. And so because of that, your y value will always be your opposite side. Your x value will always be your adjacent side. And then you have your hypotenuse. Okay. And so sine is opposite over hypotenuse. And in our picture, opposite is a fraction, 3/5. And the hypotenuse is 1. So it's 3/5 divided by 1. Nice thing, though, is whenever you divide by 1, you just get itself, right? So 3/5. Cosine is adjacent over hypotenuse. So that would be negative 4/5. Don't forget the negative over 1, which reduces to negative 4/5. And then the one that could be a little tricky, but you guys can handle it, is a tangent is opposite over adjacent. And the opposite is 3/5, right? 3 over 5. And the adjacent is negative 4 over 5. So you have a fraction divided by a fraction. And don't leave it like that. You want to simplify this. So your numerator you leave the same, and you multiply it by the reciprocal of the denominator. So flip that fraction over. And so we get negative, well, it's going to be negative because it's a positive times a negative, 15 over 20, which reduces to negative 3 over 4. If you wanted to, you could have gotten that negative 3 over 4 a little quicker by canceling those 5s out. Okay. So I want you to try the same thing on the problem right next to it. Okay. It does change. So focus on what angle are you doing. So like so the angle here, if I highlight the sides, you see that? So the two sides that make up your angle are always the hypotenuse and the adjacent. Always. So when the angle changes, then they change, right? So that's why. What do you guys get for the missing coordinate? 5 over 13. how to do it? No. So you start with Pythagorean theorem. So here's your triangle. This gives you one of the sides of the triangle. Which one would it give you? One. Yeah. The height. Yeah. So then you got to solve for the x value using Pythagorean theorem. Yeah. So if this is the reference angle right here. Sometimes, like in this circle, in this case, this will always be your reference angle, but like here, sometimes it changes, right? So if you find your reference angle and find the two sides that make that, those two sides will always be your hypotenuse and your adjacent. Yeah. Yeah. Glad you know how to do math, man.
I do that right. Would it be 12 over 13? No.
Okay, you forgot one thing. When you multiply by 169, you got to multiply 1, 2, and 3 things. So you forgot to multiply that b. Okay, so for this one, again, we're looking for a missing coordinate. We're looking for the x coordinate in this case. And in our picture, in the triangle, the x value is the base of this triangle. The y coordinate is the height of the triangle. Okay. Now, they tell us y is negative 5 over 13. And it's negative because we're in quadrant 4. That's where the negative is coming from. And so if I use Pythagorean theorem on this right triangle, I have x squared plus negative 5 over 13 squared equals 1 squared. And so I square things, and I end up with you're always going to end up with positive things when you square it. So 25 over 169 is equal to 1. To get rid of that fraction, multiply all three parts by 169. And so you get 169 x squared plus 25 is equal to 169. Subtract 25. You get 144. Divide by 169. And then when you find the square root of everything, you get 12 over 13. But you got to decide, it could be positive or negative. So think about what quadrant you're in. Should x be positive or negative in quadrant 4? Well, x, anything to the right side, so quadrant 1 and quadrant 4 will be positive x. Anything to the left side will have a negative x value. So quadrants 2 and 3 will give you a negative x value. Okay, so this is going to be positive 12 over 13. And then with our triangle, our reference angle comes from our vertex is at 0, 0. And so our x value is the adjacent side, 1 is our hypotenuse, and negative 5 over 13 is the opposite side. And so for the sign is equal to opposite divided by hypotenuse. And so that's going to be negative 5 over 13 divided by 1, or just negative 5 over 13. The cosine is your adjacent side over the hypotenuse. And our adjacent is 12 over 13. Hypotenuse is 1, so we just end up with 12 over 13. And then the tangent is your opposite divided by your adjacent side. So fraction over fraction, so negative 5 over 13 divided by 12 over 13. And so that, if we work that out, we get negative 5 over 13 times, flip the fraction over, 13 over 12. And it reduces to negative 5 over 12. That's what we wanted there. This next part here, we're supposed to fill in the missing sides for the special right triangle, so let's do that. I wanted you to memorize one 30, 60, 90 right triangle. And so across from 30, remember what side length? 1. Hypotenuse is 2, and then this is the square root of 3 across from the 60, okay? Now, the second triangle is the same triangle, just oriented differently. It's still a 30, 60, 90, so across from 30 you have 1, hypotenuse is 2, root 3 here. So those two are the same triangle. The reason we have them twice is on the first one we're going to use 30 as the reference angle. On the second one we'll use 60 as the reference. And then the 45, 45, 90, we said these two side lengths are 1 and square root 2. Okay. So we filled in the missing sides for our special right triangles. Now we want to find the angle that satisfies the following equations. And you only have to do this for these triangles. So there's only 3 possible answers. Your answer to these equations is either going to be 30 degrees, 60 degrees, or 45 degrees. Okay? And so it may be helpful at first just to write in, okay, this side will be opposite the 30. Here's my adjacent side. Here's my hypotenuse. In this picture, root 3 is the opposite, 1's the adjacent, 2's the hypotenuse. And in the last picture, this would be the opposite, the adjacent, and hypotenuse. Okay. So, which triangle would go with the first equation? Sine of theta is 1/2. And it's got to be one of these triangles, and we're just trying to pick which one it goes with. And how do you know it's the first one? Opposite, yeah. Okay. We know that the sine is opposite of our hypotenuse, and so if we look at our triangle here, the opposite is 1, the hypotenuse is 2, and it just works out perfectly. So we know it goes with that first triangle, and so we know that our angle theta is 30 degrees. Okay. And then you go to the next one. So cosine theta is root 2 over 2. Now, if you know it's one of those triangles, you know the answer. Because only one of those triangles has root 2. Right? Right? This triangle doesn't have root 2. Neither does this. The last triangle is the only one that has root 2 in it. So that might give you a clue that it might be 45 degrees. Now, let's check though. So if you're ever in doubt, check. So cosine of 45, cosine is what over what? Adjacent over hypotenuse. So in our picture, that would be 1 over root 2. And that doesn't match this problem though, does it? But you got to realize that the answers are always going to be in simplified form, meaning when we simplify radicals, we rationalize the denominator. And so we don't leave that square root of 2 there. So if I multiply top and bottom by root 2, I end up with root 2 over 2. And now you can see, yeah, it was 45. So my answer is theta is 45. Okay. Tangent's a little trickier to just see right away. Now, you can see, okay, they both have root 3. So you know what it's not going to be. Which triangle is it not going to be? It's not going to be the 45, 45, 90 because there's no root 3 in that triangle at all. So you know one of these is 60 and one of these is 30. And the best way to do it is just try it out. Find the tangent of 30 and see which one it is. And then try the tangent of 60 and verify that that's the other one. Okay. So can anybody find the tangent of theta as root 3? You're saying 60? Okay, so let's try it. So tangent, if we have 60 degrees, Tangent is opposite over adjacent, so opposite is root 3. Adjacent is 1, and that simplifies like I want it, so theta is 60. So I know this last one's not 60. I know it's not 45, so probably going to be 30, but let's just check. Opposite of 30 is 1. Adjacent to 30 is root 3. And then I multiply top and bottom of that fraction by root 3, and I get root 3 over 3. And we see theta is 30. Okay. Now, I know we're running near the end, but I want to show you something on these last two triangles here. We're asked to find the sine, cosine, and tangent on both these. You can only find sine, cosine, and tangent if it's a right triangle. This is not a right triangle. This is an isosceles triangle, so we have to split it up. Cut it down the middle. You have to make a right triangle for this to work. Nice thing is, if you cut an isosceles down the middle, it splits it into two congruent right triangles. So this is going to be 15, 15. So you're just going to work with the left half. So this is A, 17, 15. And then you'll have to find this value using Pythagorean theorem. And then you got it. And so you'd have to finish that. I'll let you do that. Now on this last one, if they tell you the tangent is of B is 12 over 5, well, this is the opposite side of B. This is the adjacent side of B. And so this would be 12. This would be 5. And then you can use, we'll call this H. You can use Pythagorean theorem again to find H. And then you can find the sine, cosine, and tangent of angle A. Right? We'll stop there.